Hey everyone, this is Jeremy from Automated Manufacturing. Today I'm going to be walking you through how to set up the probing routines in Fusion 360 to probe and locate your work coordinate systems for multiple parts on the same pallet. This pallet's used in our robotic machine tending system, and the parts need to be probed every time. They don't locate in the X direction, and if we want more precision, we need to locate them in the Y and Z direction. So the cam setup we're going to be going for here is use this master location feature to define our X, Y, and Z locations on every work offset for each of these parts. Every work offset will relate the part to this position. That makes it a lot easier. You only have to probe one feature to get all your work offsets for each part. Set up in our CAD workspace, we want to make sure we're including an offset of the parts for the stock that there's going to be. For this part, there's 5 millimeters of stock, so I just edited the joint command to offset it 5 millimeters from our Z0 face. Once we're happy with how our parts are located on our pallet, we can go into the manufacturing workspace. So the way we're going to be setting our work offsets for these parts is our master offset, G54 through G59 plus P1 will all be located off of this sketch point right here. But this part is going to be G55, this part G56, 57, 58. Both of these parts will be G59. Both of these parts will be extended work offset 1. But again, they're all going to be located at this position. When we probe them, it's just going to slightly change this position to actually match the part. That's how you can have individual setups for every single one of the parts while only having one master location. Now, the reason we do this is because it's easy. We can populate G54 through extended work offset 1 using the same point. Now we're doing that through this manual NC code. If you want another video kind of explaining how we're populating these offsets, then we can go through the macro code to do that, but it's not within the scope of this video. So just know I've already located this feature and I have the X, Y, and Z master location right here, and I'm just populating G54 through P1 using this manual pass-through. Now we're also using it for setup instructions and a tool check because our system can evaluate whether the pallet in the machine has the appropriate tools available. If it doesn't, because we've broken through all of the tools in the tool group, then it will kick the pallet out and put a new one in, and maybe we'll have all the tools for that one. If you guys would like another tutorial on basically how we did this, just post a comment down below. So we're going to go into setting up our probing routines. First, we're going to probe this feature, this rectangular pocket in X, Y, and Z, and it's not completely necessary, but we can use it to verify that we're even in the right pallet before continuing on and maybe hitting something we don't want to. So let's create our first setup. Define X, Y, and Z. Now our origin is going to be this master position. This is going to be G54, and we want the stock to be from solid. Doesn't really matter, but G54. And we're going to set up our probing routines to probe our feature. Our probe is tool number 30. We're going to want to probe these 4 faces. Rectangular hole. Our bottom height only -3. And if we wanted, this is where we could check if it's the wrong size, out of position, make sure we're actually even going to be probing the right pallet. We don't care about that for now. Now let's go ahead and probe Z. We're going to probe this bottom face. Now be careful here. On our bottom height, we don't want -3, we want 0. We're basically saying this position is 0 from what we think it is. Our Z0, of course, is actually this top face. And this bottom position here is actually Z minus 5. But if our bottom height says -3, it'll think that this position is -8. So make sure to mark that as bottom height 0 for appropriate Z results. Let me bring that sketch point back up because we're going to be using it. So now that we're happy with that, we should be able to define our setup for our very first part. This is going to be G55. Select the right model. We'll do fixed size box. This is going to be work coordinate system offset 2. Select our Z, X, and again, our origin is going to be our master offset location right here for every single one of these parts. So our bar stock on this part is going to be 1 1/4 by 1 inch by about 20. Actually, no stock offset on the side, so 22.5. Y is the 1 1/4 inch. Now Z is the 1 inch. And we're going to offset it from Z bottom. Now remember, in our CAD setup, we made it 5 millimeters from this face, so here we can offset it by 5 millimeters. Work coordinate system offset 2. Okay, we should be happy with this setup. Now we can come in and do our probing routine. We only need to locate this part on its X face. That's the advantage of setting this position as our X, Y, Z 0 for all work offsets at the very beginning, is we now only need to probe X. We're happy with this Y being on this landing, and we're happy with Z being from this face because we're going to just face the top of the part off anyway. Now we do want to check this override driving work coordinate system offset box because we want to probe around in G54. We could probe around in G55 because it's the exact same offset as our G54, but this is better common practice if you're going to do other kind of probing. You want to be probing in your master offset. So we should be happy with that. We've relocated our X. Call this G55, and we can move on to our next part. Oops. We're going to set it up the exact same way. Select a point right here. This will be 3. Stock will be exactly the same as our other part. And Z25, 4. Just make sure to select this model now. And we should be happy. We can copy and paste. Call this G56. And select now the opposite face. 1, 3. Good. So now for our next part, we do have stock on the X and Y locations, and we'll be probing it in X and Y. This will be work offset G54, 5, 6, G57. The X exact same starting location. Our X is going to be 23 millimeters. Then again, it's just 1 1/4 by 1 inch bar stock we're going to be using. Now our offset on this part, if we measured it, is actually 7 millimeters from these 2 points. So we'll mark it 7 and see that the stock comes down flush with this face. I just copied and pasted our probing routine. And now what we can do is, instead of probing the model, which we wouldn't be able to do in Y very well, we can probe the stock. And we have our defined stock right here. We'll probe it in X and Y, just like this. Still exact same method we're using right here. And we should be all happy with that. That's our G57. So I would do the exact same thing on this part, but it looks exactly the same. So I'm just going to move on to how I would do these 2 parts and then locate these 2 parts off this feature. So let's go ahead and do that. This part would be G58, so this part's going to be G59. Let's define that setup. We're going to select both of these as the model. I'm going to do relative size box on this one because we're only going to have the 5 millimeter top offset. Still, this master work coordinate system, I'm just defining the top offset as the stock that would be left on the bottom here. This part is being flipped over and just decked. That's all. This is a second operation for this part. These 2 parts here are the second operation for these 2 parts. This pallet just delivers 2 parts every time we run it, which is we make the parts when they're ordered. So we should be happy with this. This is again going to be 59, which should be 6. And again, we only need to probe the X position. We don't want it to be too far off. So G59 here. We can again pick the stock offset, or in this case, we could have picked the model offset because both of them are flush with each other, but this will work just fine. And this same method, we're good with our 59. Now we're going to do our extended work offset 1 to locate these 2 parts off of this feature. Seven will indicate work offset, extended work offset 1, 8, extended work offset 2, and so on. So fixed size box model. We're still just going to select these 2 models as our feature, and again, we're just decking these. We're decking these, so our top offset is going to be 7, which will match the offset the part is from this face. Looks good. So now we're just going to probe this feature to locate these two. This acts as kind of a soft jaw to hold these two parts into place, and we should be accurate enough. I mean, we're just facing here to probe this feature and get those locations. If we wanted, we could deburr as well. Um, but for this part, it's unnecessary. So our approach, I believe, needs to be shortened because it's such a small hole relative to the size of the stylus we're using to probe. So I selected both of these parts to have the stock because then when we go to make our machining program, we can actually, it'll automatically know the facing dimensions to use. You want to be concerned about is your retract heights need to clear all the parts on the pallet. Between these operations, when you post it out, the probe's not going to go home. It's just going to go to your retract height and then move to the next operation. Now, when it does this, it's also not going to be in protected positioning move, which is annoying. Fusion should add a feature where the probe can detect the next operation, is also probing and keep it on and keep it in protected positioning move, but it doesn't. So that's something to be careful of. Now, another thing you want to be careful of is what you might be tempted to do is go into this offset and then start adding your machining programs. You know, maybe I'll add the facing operation here. But you'll notice you run into a problem if you do this and try to post this out, then you're going to be probing, then cutting, and so on. You're probably going to end up probing some chips. So you need all your probing routines at the very top of your program. What you can do is when you come to post this out is check this box, reorder to minimize tool changes. Now this should move all your probing routines to the top. And that might work for you if this order of operations is okay. Now, it doesn't work for us because we use so much of this manual NC for broken tool detection and logic that reordering it will also reorder those, and that just doesn't work. So what we actually do is we do include the machining programs within each of these setups, but after posting the code out, we run it through our own post processor that has the ability to reorder the probing routines to the top. But if you don't have that and you can't afford to reorder the operations, then what you're pretty much forced to do is copy the setups and have probing at the top and then machining at the bottom. So I'm just copying and pasting the G55 setup. And on this one, I can just delete the probing. And then when I go to post this out, it'll all be in the correct order. I know that's annoying because you'll have twice the amount of setups, but Fusion's a little bit limited in that way. I wish that there could just be a checkbox here, maybe a checkbox somewhere that lets you reorder the probing routines to the top, but Fusion doesn't have that, so those are your options at the moment. So when you're happy with all your setups, you can go ahead, highlight them all, post. Make sure your post is capable of inspection. Although we're on a Mitsubishi control, the Fanuc inspection post actually works just fine. It is just a 3-axis machine, but make sure you're using a post that has inspection capability and works for you. This is just the way we found that works for us, but if you have a better method or a better way of doing this, feel free to comment it below. It doesn't feel like the best way or the best workflow that there can be, but it does work. If you guys have any other questions or comments, just leave them down below or visit our website at automatedmfg.com. We're happy to help and specialize in robotic machine tending and Renishaw equipment. So we'll pretty much help anyone out. Maybe not certain countries in the Middle East, but mostly everyone, we're happy to help out. Now I'm going to play this running on our machine, and you can see it working in real life.